All right, welcome everyone to this week's or this month's innovation seminar. The speaker for this month's innovation seminar series is Dr. Buddy Clark. So Dr. Clark serves as a professor in Pitt's Mechanical Engineering and Material Science Department and is a co-founder of Diamond Kinetics, the Pittsburgh-based company that produces data-driven bat swing and throwing systems for baseball and softball training that you're going to be hearing about today. Dr. Clark has been awarded at least a half dozen Pitt Innovator Awards over the last decade, including being named the Pitt Innovation Institute's Marlon Minkle Outstanding Innovator of the Year in 2019. Dr. Clark was also recently selected as a member of the 2021 Fellow Class of National Academy of Inventors, which is the highest professional distinction accorded to academic inventors. So Dr. Clark has a lot to say about inventing things and being an innovator in this field, and we're really excited to have him here today. So let's give him a warm welcome, and you take it away, Dr. Clark.
Thanks, Alex. So I've known Alex since she was a student in several of my classes, getting her minor in mechanical engineering. It was a minor, right?
It was.
As a bioengineering student. So yeah, Alex and I've done some projects together. So it was actually an honor. I appreciate you asking me to be here. So this should be fun. I hadn't actually put together the story of Diamond Kinetics, even though CJ and I talk about it a lot, you know, everything that we went through. So it was fun to pull this together. And I feel like I only scratched the surface, but I want to give you a feeling for what it was like. And I know there were people on the call probably contemplating entrepreneurship or have been there yourself. And so I want to make sure we at least include that sort of aspect of what's it like to take a company from the lab, you know, out into the corporate world. So, so I will make sure you can see my slides, right? All right, good. So, like I said, this is going to be a brief review of the start of the company. It's Alex gave a pretty good introduction, but you know, our latest description of what we do is we utilize technology to create engaging experiences for players to help them improve and have fun in the game. And it actually started to go even beyond the players. And I'll get into that a little bit. So, you okay?
We just ask if everyone would mute upon entry into the seminar. Okay, you're good to go.
This is, like I say, it's only about the beginning. I could go on for hours about what's happened since then, all the changes in the company that, or all the innovations that we've done since the very first product. But I kind of take it up to the first product launch and leave it at that. So maybe we'll do that at another time and go beyond it. But I do want to give a brief snapshot of the company. So CJ Handren and I co-founded it in 2013. And right now, sort of where we stand, we of course have been and currently are located in Pittsburgh. We have an office on the North Shore in the Riverside Center for Innovation. We have about 30 full-time equivalent employees in the company. A lot of which are actually scattered around the country. It's amazing what COVID has done to employment now. We realize they don't have to be physically there anymore, and that helps a lot in able to recruit. And that's an aspect that's blown me away over the years, the fact that we employ that many people. So a fun, for me, unexpected aspect of entrepreneurship. We have 3 hardware products. You can see them on the screen here now. I'll touch on them a bit more as we go. We have a whole suite of mobile and web applications to support those and to provide the interface to the users. And then we've got multiple partners in baseball and softball throughout the industry, from all the way from the youngest ages all the way up to the professional leagues. So the products themselves are all about baseball and softball motions and capturing those motions and conveying that information to the user. So the original product is what we call Swing Tracker. It measures the swing, tracks the swing. And they're all inertial measurement based. I'm going to get into that a bit more later. But they're sensors that mount, in this case, to the bat, either on the knob of the bat or embedded into the knob of the bat. You can see in the wooden bat there. And they basically capture the motion of the bat at all times. As long as it's on, it's capturing motion. And when a swing event occurs, it collects that data, transfers it over to a mobile app, which interprets the data, provides a whole bunch of feedback to the user. And then eventually the data goes up to the cloud and stores it there for later retrieval and data analysis and so forth. So that's the hitting product. The pitching product actually takes two forms. There's one for fast pitch softball players and one for baseball players. There are smart baseballs. So they take the same inertial measurement technology, and it's embedded in the balls themselves. The balls actually look and feel identical to real baseballs. In fact, the same company that stitches professional baseballs is the company that stitches ours. So if you were blindfolded, you wouldn't know the difference. They look and feel the same. And similar to the bat, they measure the motion of the ball at all times. So you move it around during the pitching motion, when you release, during free flight and the spin. It captures all of that information, converts it in a manner into metrics that are useful, distills it down, and then conveys it for analysis later. So between the hardware and the software, those are our primary products at this stage, and they're constantly evolving. So where did it all start? So as the title suggested, it started on the ball field. And by some measures, this has been, you could even say, a 20-year effort that started when my kids were old enough to start playing. And they were the motivation for this company. So, and you'll understand that better as we go along here. So these are some pictures from the early days when my wife and I were coaching multiple teams. Sometimes during the same season, we would be coaching 3 or 4 different teams, trying to engage all our kids in the game. And so you can probably see me in a few of these pictures. But to point out, there's my oldest daughter, Renee. There's my son, Russell. I think that was when he was 10. I think that picture above was probably when Renee was 10 as well. I think these are different times. There's my youngest, Alyssa, when she was playing t-ball. And my wife got into the coaching game too. She was there. And so for us, baseball and softball were a way of life as much as just activities that the kids did. And it kind of goes back to when I played, when I was that age. My dad coached me in Little League, and we would come home at night, and after games, we could spend, it felt like hours, rehashing the games, everything that happened that day, and reliving the games, breaking them down, talking about what was good, what was bad, and we were all into it, the whole family. And so, it was very impactful time for me, not only because of the, just the joy of doing it, but as an engineer, I was often left frustrated. The coach in me loved it. The engineer and scientist was frustrated, and partly because there was a shortage of innovation in the game. And so if you look at the state of technology for improving players and coaching at that point in time, it was pretty much outdated. There hadn't been any major innovation for, you could say, anywhere from 30 to 40 years at different points of that stretch. And the last real innovation that affected baseball directly was the radar gun. And it was introduced in the 70s, and that was even at the highest levels. And then you could say the video camera, at least the commercial grade video camera, also made an impact on coaching because it allowed, obviously, people to capture an event and then replay it and study it. But again, that technology was 30 to 40 years old by the early 2000s to 2010. And so really, if you think about it, set aside the radar gun, which was very limited in its application, primarily to pitching and pitching velocity only. The coach's eyes were still the primary instrument for measuring motion. And this isn't just in baseball, this was across sports at the time. So that left a lot to be desired. And so just to test us all here for a second, we're gonna do a quick test. We're gonna use that primary measurement tool to analyze the swing. So I'm gonna play it here. All right, so did everyone get that? That's how it worked, right? The swing happened on the field, and it was then up to you to think about it. So ask some questions. Was that a good swing? These can be somewhat rhetorical, but feel free to unmute if you have a thought.
Buddy, it's Mark. Can you hear me?
Yes.
So is the proper weight transfer from the back leg to the front leg?
That's a good question. That's one way to look at it. So that even raises a question of, I went ahead and asked how good. So, what is proper if we're talking about weight transfer? That would be another, quantification we would want to do. So, if it was good, how good, how fast was it? There's a metric we can break down that's very specific. How much momentum was generated in the bat? Now we're getting more technical because the ball bat collision is an impact momentum problem, right? So it's all about converting impact momentum in the barrel to momentum in the ball to get that exit velocity that everyone wants these days. And that term didn't even come about until the last decade. People really didn't consider, at least not openly, exit velocity. And then so the following question is how much momentum was transferred to the ball or how much energy. Then we can even talk about how efficient was the swing. So, and even how efficient was the impact. So now these are all, real engineering terms. How much energy was in the bat compared to how much was transferred to the ball? Was the collision efficient? Was the swing efficient? Can that player generate more energy in their body to convert to the bat, which converts to the ball? And then that was just for one pitch and one pitch location. How does that change across the zone as the player tries to hit the ball in different locations? And then the key question is, how can the player make it better? That's what they're all after. And it doesn't even have to apply to a player that's has aspirations of playing in college or pro ball. This applies to the 6-year-old child that just wants to do better on the field and get more enjoyment out of it, right? It's a whole lot more fun to hit a double into the left center gap than it is to ground out to the pitcher all the time. So, there's satisfaction in that. So, so these are all questions that I wanted to learn more about and just couldn't because the tools weren't available. If you now see the questions and think, well, maybe I could interpret that differently, let's see it again. Anything different come to light about that swing now? Did anyone actually recognize that that was a different swing? I mixed it up on you and actually showed a different video the second time.
I noticed there was one less person in the background when she gave it away.
that was the tip off. Yeah, so actually let me go back up. And the benefit of video, at least, is we can scrub the video and see. So I can scrub this in slow motion. There he's loading up. Now he launches the swing, and we see the ball exit. So this was actually recorded at high speed. So we could play it back. 30 frames per second is nowhere near this good. But even at that, the IMUs that we're going to talk about are way higher rates, so we can get even more data. This is actually a really good swing. You can see by the name on the front of the jersey, this is not your typical high school player. This is a player that's done this a few times. And you'll notice some important things. For example, the barrel is moving at a certain angle, and the ball then is launched at even a slightly higher angle. So that's a really good launch angle, and that ball would probably be, it was well hit in a ballpark. Whereas if we go to the next one, so everything looks very similar at the beginning. And if you look carefully, you'll notice the body and the bat are moving a little differently than in the last swing. And it actually results in we'd say he's jammed on that pitch. And the ball exit is way different. You can see the barrel's still coming up slightly, not as much as before. And the ball takes an entirely different path. So partly because he mishit it, but partly because, and the reason for that is probably due to the way the swing was a little messed up. But we can now see all of that information in the swing without analyzing the video. And you can see even with the video, it's hard to get quantitative information. So those were the kinds of things that we were dealing with as coaches and players in the early 2000s. And not only was there a lack of information, a lack of tools, there were a lot of unknowns and a lot of just plain myths. So, you know, Mark's question was a great example of, well, how does weight transfer matter? You know, people had a widely diverse opinions on that, and there wasn't really any good concrete information to answer those questions. So, so again, those were some of my frustrations. And here's an example of one of the most common questions that I would get as a coach. What size bat should my daughter or son use? At the time, well, this is even well after those early days. In 2010, when I really started looking at it carefully, there were about 200 youth baseball bats on the Dick's Sporting Goods website, and about 170 fast pitch softball bats. So if you were a player or, you know, a parent wanting to get a Christmas present and you bat for your child, your guess is as good as mine as to what's the best bat, right? It was a real unknown as to what was the best one to get. Now you could maybe narrow it down to bats that were similar to ones that you saw other players swing on the team, get the length fairly close, but even at that, there were lots of different drops, different models, so a wide variation. Well, it turns out, even though there were no good tools to answer that question, it's a biomechanics question. The goal is to, I mean, there are different ways you could analyze that, but it is an optimization problem. So one way to optimize it is to try to allow the player to swing such that they can generate the maximum energy in the bat that could then generate the maximum energy in the ball. We could do other things like try to get the most consistency or the most control, but nonetheless, we could quantify that problem and treat it as an engineering problem. But in order to do that, and that's one of the things, in fact, that is the question that led me ultimately to Diamond Kinetics. To answer that question, though, I needed better sensors. There just weren't enough sensors, as we've talked about before. I needed to get information about the bat swing in order to dig down and figure that out. So I set out to the lab to try to answer that. And along the way, I contacted a colleague of mine at the University of Michigan, Professor Noel Perkins, who works in the dynamic systems area. He's more of a dynamicist than I am. But he had been working with this new type of sensor at the time called a MEMS-based inertial measurement unit, or an IMU. And these were actually brand new devices at the time. IMUs existed in their various components in fields for a long time, but putting together and at the scale that MEMS allowed on a small portable device that could be worn or placed on equipment, that was pretty much brand new at the time. In fact, IMUs didn't exist. The components did, and he put them together initially on boards in applications. And as an aside, he and I would meet often at conferences and different events, and we talked a lot about one of his pet projects, which was to put these sensors on a fly rod and measure fly casting, because he was an avid fly fisherman. And if any of you have ever fished, fly fished, you know how difficult it is to learn the casting motion. And he wanted to basically analyze it the same way I wanted to analyze bats, basically. And I realized that was an optimal solution for what I needed. And so we talked a lot, and eventually that's what I adopted for what I needed, and ultimately Diamond Kinetics. And I did want to just take a moment to point out, I think Noel is one of the leaders of the field in sports motion analysis, and he used IMUs in lots of things. So he started with fly fishing. He then moved to golf clubs. He actually analyzed bowling balls. There is a ton of really cool information about bowling ball dynamics that I never thought existed. He analyzed bicycles and riding bicycles. He did actually analyze bats and balls about the time we were coming out with our products. And he further went on into human motion analysis for the military and for other applications. And he's still doing it. I think his latest paper was on ski poles and how skiers change their pole orientations during ski runs. So anyway, back to my work. I undertook this study to figure out optimal bat and settled on a method that relied mostly on bat speed measurement as the primary variable to optimize on. And in a nutshell, came up with a method that plotted, I don't know, can you see my cursor? Okay. Plotted basically estimated ball velocity, or it actually measured bat velocity, that's the blue line, and then estimated ball exit velocity if there was a really good impact, versus basically bat weight, although it's bat MOI, mass moment of inertia, which has allowed me to put it on to one variable. And the way it works is, and this happens for all players, if you swing a bat that's too big, you can't swing it very fast. So the bat speed goes down. And at some point, that bat speed then is too slow to actually generate good ball exit speed. So it's bad to swing a heavy bat. On the other hand, if you swing a bat that's too light, you can swing it really fast. So here's your speed up here, but there's just not enough mass or momentum in the swing to give good ball exit speed after the collision. So exit speed's bad. And so what you get is this sort of optimal peak in the middle. And somewhere in that peak is your optimal bat. So essentially we've modeled the human body for the player and how they can, and it's a personal thing. It doesn't matter how tall you are or how much you weigh. There's a lot of other factors in there that you can't pull out a single variable about the body. As we found, you had to study it per individual, and we could identify where that optimal was. And but to do that, we needed a good way to measure bat speed. So I borrowed some ideas from Noel as to how to do that, and created that bat speed sensor. We were also doing other work in the lab at the time. Minmin Zhang is my PhD student who was studying IMUs for throwing motions at the time. And he was putting multiple IMUs on a player's arm, which was rare. There were very few multiple IMU studies at the time. And he could measure the motion of the arm, both the upper arm and the forearm, through the entire pitching motion, and then go further and start to analyze the kinematic chain. So I think we're all familiar with the fact that we get all our forces from the ground when we do a motion like this, and they come up through the legs, up through the body, and eventually out to the ball as energy gets pushed out to the ball. And sequencing the motions of your body parts matters a lot in optimizing that throw. And he was able to analyze that with these multiple IMUs, and it clearly separated out the sequences. So that's the kind of work we were doing in the lab. And I wanted to take just a couple of minutes to talk technically here and look at how do IMUs actually work. We hear them a lot. We hear about wearables, but what's really going on there? Well, an IMU is a multi-sensor device that measures multiple axes of motion. And specifically, it's got an angular rate gyro, a triple axis gyro in it. So it measures angular rate in 3 axes, and it measures acceleration in 3 directions. And often there's a magnetometer as well, which measures the Earth's magnetic field in 3 directions, but that's usually used maybe for special purposes or error correction. So we're going to ignore that for now. We can then integrate the angular rates to get angular orientation of the sensor, and we can integrate the acceleration to get velocity and position of the sensor. So in theory, we can get all the degrees of freedom of motion and all the derivatives. But usually the sensor is oriented arbitrarily in space, right? Because it's moving around on the body or the bat. And that means gravity is added to the acceleration signal in some arbitrary orientation. So if we were to integrate that signal as it is, it would get greatly distorted because we're integrating that gravity signal, which is actually not part of the motion. So we have to subtract that out, but we don't know which components are in which axis of the measurement because they're arbitrary. So what we do is we take the angular orientations that we have already found, and we rotate that sensor back into the gravity field so that now we know G is always pointed in the we'll say Z direction, and then we can subtract it out and we can do our integration, and now we've got all the numbers we need. So now we know where that sensor is moving in space at all times. Now, one more caveat, it assumes that we know where it started, which many times we don't. So we really know the change of position and orientation, but if we can make good assumptions about the starting point, then we can know where it moved. So that's the quick physics lesson. Once we've done that, like I say, we know where the sensor moves for all time. We can attach that to an object, say a bat, and if it's rigidly attached, then we also know where the bat moves in space and how it's oriented. And then we know where every point on that bat is moving in time. So that's how we get the bat motion. And then we can track that. Now, not only can we see it, if we were to videotape it, we can calculate the exact positions and orientations, and we could get all kinds of other information, like I was asking before. We can know momentum, we can know vectors of momentum, we can know changes in angles and all this kind of useful information. So between knowing that information and having some tools for the throwing motions and the pitch, the bat optimization, seemed like we were onto something good that was worth more than just keeping it in the lab in some studies. So I thought about, maybe we need to consider commercializing this. So we'll talk a little bit about, how did I get there? Where did we go from there? So problem was, I was not entirely sure how to go about it. I felt like I had something, but I had a rough idea of a business model. I had a prototype that, even though it just used off-the-shelf IMUs at the time, I knew I'd have to build my own, but I knew the concept worked. I had a patent application because I had applied for a patent for the bat optimization method primarily, with some other things there. Of course, I had my MATLAB code, which wasn't going to help me in industry or in the commercial world, but at least it was the basis of the algorithms. And I had some pretty good certainty that it was the right time to do it. But that's about it. So I first step was I was pretty certain that I wanted to also get Dr. Perkins' patents from the University of Michigan, because they were some foundational patents for using these sensors in sports devices. So I thought, couple that IP with mine, I thought I had a pretty good thing. And so it turned out that that IP had been actually licensed at one point, but then that company didn't progress with it. So they pulled it back, and then they had an open competition for people to apply for it. And I knew about it because I was in close contact with Noel. And so I applied for that. That was kind of me biting the bullet and saying, I'm gonna go for this. And I must have had a decent business model or plan, because I was selected. And for all I know, I was the only one that applied. But anyway, I signed an option agreement with them in 2012. So I had to form an LLC to do that. I guess there's something legal about that. It felt like it was still just me as an LLC, but that got that checkbox marked off, and I was allowed to get an option. But I knew there was still a lot of work to be done, and still a lot that I didn't know. So with all those resources in hand, and knowing that my IP at Pitt was still sort of sitting there to be licensed at when needed, I went on a search for more guidance. And so I went to the Institute for Entrepreneurial Excellence here at Pitt. I actually went to the Small Business Development Center, which is all part of the same office, I guess is one way to say it. And they pointed me to the Panther LabWorks folks, and got connected with CJ Handren. And that was the best, best event or step in the process, I think, in the life of the company, was me meeting CJ. That turned out to be a perfect fit. I knew at the time that I needed a CEO. I was not, I don't think, well equipped to be a CEO, nor did I really have the time to take on that big of a task. So I was actually on the search for a CEO, as well as trying to move the business forward myself. And I went to CJ basically with that in mind. He likes to say I walked into his office with my bat over my shoulder and my laptop in hand, which I probably did that day. And I think his ears perked up, because he was a huge baseball fan himself, growing up playing the game. So it was a really good fit, and we learned that over the coming year. We worked closely together to hone the business model, define some milestones, to really figure out what needed to happen in order to make this work. And one of the big things was just really finding evidence of interest in the market and finding a value proposition. And we found that in a couple of areas. It's interesting, those didn't really come to fruition the way we originally thought. And I think that's often the case in these types of ventures. But it was enough to really give us evidence that this was something we should move ahead with, and it was investable and we could go. One was Dick's Sporting Goods. I had been working with them since the early days, trying to get them to be interested in this bat fitting concept, as something they could put in their stores and help kids learn how to fit the right bat. And we had done a market study with them in January of 2013, and it was really positive. It worked out really well. So that was one thing. And then CJ had been working with USA Baseball for quite a while, since our beginning discussions, to kind of look at the interest at the high level of the game, to see if there might be interest in adopting that kind of technology for training purposes. And he got good feedback there. And so I think those 2 points really made us realize, this was the right time, and it was enough to convince CJ to step out of the university and partner with me, and the two of us took this thing and ran with it. So we incorporated as a C corporation in 2013, and CJ was co-founder and CEO. So this was our baby to run with now. And our goal at the time, and we still look back on this, was to make an impact on the game. That's a somewhat vague notion, but knowing the technology at the time, we felt like we could do that. We really had the chance to make a big impact and change the way people thought about data in this game. And honestly, I think that started to happen now. So what else happened? Well, there were a ton of things that had to happen at that point. First of all, all the internal stuff, me getting through Pitt's conflict of interest process and dealing with general counsel, which is, I think, in not so much conflict of interest, but just the perception of faculty innovation and entrepreneurship is unrecognizable, I think, today from what it was then. It's changed that much in the last 10 years that it's much more accepted and even encouraged now. So, and I do appreciate the changes that have happened in the university in that regard. But we were able to get some initial funding with CJ's help and did things like we did develop our first hardware. Remember, I said it was off the shelf in our prototypes. Now it was our own. We built our own, which included firmware, an iOS application. We actually got a real office somewhere along the way, besides meeting every week in Dunkin' Donuts on Route 8. We had to go through Bluetooth and FCC certification, design plastics and packaging, build a website, get even more funding. We made our first hire, which was Jeff Schultz, who's still with the company as the chief commercial officer. Another quick note, my take on entrepreneurship is you just keep hiring people to do things you don't know how to do, right? And CJ saw a void on the marketing and sales side in his own knowledge base. And so he filled that void, right? And we've done that ever since, filling out those holes. So Jeff's been great. And he helped develop that marketing and sales plan and then lots of other things. But in that 1.5-year span, we were able to get enough done that we actually had a product and we started selling in November of 2014. So and that's it in the picture. Quite a bit different than what we have now. We've undergone several iterations since then, but it was enough to get us out there. So I'm almost done with the whole flow because that's our product launch. But I did want to just take a moment to say, as we went through this, there was a process for sure. And CJ helped immensely in that and thinking through how it needed to be done. And, there's the typical prototyping and app development and, planning, financial planning, and who's the market and how big is it, all that sort of stuff, seems very logical, right? But there were a lot of times when what it really felt like was that. And so it's like, you feel like if you don't get this license with the terms that are good for us, you've fallen into the lava and you'll burn and, never recover, right? Or there's all sorts of things that feel like they're just going to cause you to die in a moment's notice. Or, then there's competitors come on the scene and now we've got to increase the speed and things take on even more urgency. And so, it feels like that a lot of the time, but I have to say that it kind of goes back to that passion. Sometimes that passion is important to get you through. So make sure you choose wisely if you're going to go into a venture like this, and pick good people because they help sort of keep things calm. You can always deal with whatever's thrown at you. You don't have to panic. And CJ and Jeff and all the other people we brought on board have been that way. So that's helped a lot. So since then, We've done even a lot more. I could go on for quite a long time, but we've added partners, employees. I mentioned the baseball beyond the swing tracker and the softball. Lots of app revisions and lots of new things have come along since then. Just recently, we were able to announce that we are the trusted youth development platform of Major League Baseball, which opens up a lot of possibilities for us. We're really excited about what that's going to allow us to do to reach the youth market primarily, but also their parents and coaches and just fans and baseball in general. So we're continuing to innovate. And it's amazing to me that, every year we take millions of athletic events, swings and throws, and we convert them into information and experiences that I think have an impact on players and fans and coaches and all sorts of constituents. So it's been fun, and it's we don't know where it's headed, but we're still going hard at it and not slowing down. So this it's been a lot of fun, and I appreciate the opportunity to share it with you.
All right, thanks so much, Dr. Clark. So we'll open it up for questions and encourage everyone to join in and kind of ask questions about this process and go forward. So thanks so much. That was a great presentation. All right, so I can kick us off. I had a couple questions for you. I guess coming from an engineering background, I was thinking about just the design iterations and the things you had to go through to make sure that adding this to the bat didn't affect like the structure of the bat, the integrity of the bat, and all of those things. I was recently watching a baseball game and the bat split right in half when the ball hit it. And I'm thinking, if you put something at the bottom of it, does it act as a cork and prevent, what does that look like? And how much, obviously, time and effort did you put into that part of it?
Yeah, great question. So a lot of time and effort. I'm going to stop sharing for a minute, unless we need a slide. There are lots of organizations that monitor that sort of thing, and there are regulations that each bat must meet in order to be used on the field. So for even Major League Baseball, for example, they have a lab up at the University of Massachusetts at Lowell that does testing for that. There's another lab out at Washington State. And so we've had to send bats to both places to do testing. And of course, we do a lot of testing ourselves to make sure these things survive and pass to be used on field. So there's actually quite a bit of time that goes into that. You basically take bat, support it, shoot it with a baseball at, 160 miles an hour or something, or different number, and shoot it and hit it in all different directions to make sure it doesn't splinter or fall apart, or your sensor doesn't come flying apart. And then we've had to iterate on the sensor as well to fix problems that we found in those tests. So yeah, that's a really good question. It did take a fair amount of time, but we passed and we're out there.
Gotcha. Is there like a threshold too? Because it still does happen, right? You see it happen out on the field, or things like that do happen. So is there like a number, like you can, I don't know, like a threshold that you have to meet?
There are specifications we have to follow, and there's a little bit of subjectivity in the testing, but it's almost to the point where if it fails, if something shatters during the test, it's probably not going to pass. So, same for the bat. If you drilled into the bat knob and that caused it to be weak such that it split apart, it's probably not going to pass.
Gotcha. Well, thank you. Well, it looks like we had a question in the chat. Someone's mic wasn't working, but said, at what point did you have to hire engineers to develop your product, or did most of the development happen academically? Yeah,
really good question. So the concepts, I like to think of it as like proof of concept prototypes that we knew it was going to work. That happened academically, but hardening that for all the edge cases that we run into happened in the company. And so as an example, like when we test in the lab, we're quiet, we hold the bat and then we swing. Well, the player doesn't do that. Like the player's up at the plate, they're like moving it around and identifying that kind of a swing and getting accurate data for that is far different than the quiet motions we used in the lab. That's one example. So all of that kind of stuff happened in the company. And that was done by an engineer. So it was me for a while. Until once my PhD student graduated, he graduated in 2014, I think it was. So we hired Min, and he's been my savior in that. He's amazing, brilliant guy. And he worked on all of that. And then since then, we've hired other engineers as well.
Great. There's another question as well that said, what was the biggest pivot on technology you had to make through the iterations? And was there any surprises in human performance during the use? So you started to touch on that a little bit, but.
Yeah. So pivots in the technology. I think one of the, and I don't know if it was a pivot so much as just a realization, one of those shocks that hit us when we realized our sensors were not good enough for the top end players in either acceleration or angular rate. Because really good players just are too good for the technology at the time. And so that meant we had to come up with algorithms to compensate for that and to regain accuracy, even though they saturated. And we did that pretty well, but it threw us for a loop for a while. Since then, the technology's gotten better. So for example, the range of the accelerometers and the gyros have doubled at least, and we can do even better now. So it's made that less of an issue, but that was one big thing that we didn't foresee.
It looks like Mark has his hand raised there. Go ahead, Mark.
Yeah. Hi, buddy. Hey, this is, I sent you a private chat about having been coached by my dad and then coached my kids. So that, I wish I had known that all the time. We've been working together. This is another side of you. This is just strictly from the baseball side. What's been like kind of the biggest change, having this data? Because you're right, all those times with kids and trying to figure out bigger bat, lighter bat, heavy bat, all of those variables. What do you think? What's been kind of the biggest change maybe since you started?
So, yeah, these are all great questions. We could talk for hours on this stuff, but and I wish I had known. We could have partnered up as coaches. Probably, so a couple things. One is just a better understanding in the market of what some of these numbers mean. Back to Marit's point or question, that was a big surprise to me too. I kind of thought, we'll give people numbers, they'll know what to do with it, because I did, right? But that was not the case at all. People are really reluctant, or it's hard for them to understand this stuff, right? So we had to provide it in ways they could, but that started to change. So things like exit velocity and launch angle, those are two numbers you never heard 10 years ago, and now they're like all over the place. StatCast is showing that all the time. Player hit 107-mile-an-hour ball into the gap. You hear that sort of stuff. So those things, that's probably the biggest change, is just a gradual uptake of that information. Still a lot of myths about how those things happen, but it's changing gradually.
And just a follow up, did any of that data then, did the bat manufacturers in particular, let's say, are they grabbing that data and saying, okay, and then promoting like our bat is better, we have a bigger sweet spot, or we get, where I'm headed, right? Or do we, yeah. So any of that? Well,
they're really constrained in what they can do because of the regulations that I mentioned a minute ago with Alex. BB Corps regulations, and now USA Bat has their own standard. They really clamp down on what a bat's allowed to do. So it's hard for a company to differentiate in terms of that type of thing, or else they don't pass the test and then they can't use the bat. There are ways that we can help differentiate, and we're just now getting to the point where we can do that. And I can't really disclose too much about it, but if you pay attention, that stuff will start coming out in the next year or two. So it's actually a lot of fun for us at this time because we're just at the point where we can start to help companies do that sort of stuff.
Hey, buddy, it's Dave. Hey,
Hey,
it's
Dave.
great. It's great to hear this story. I really appreciate you sharing this with us. So, Mike, I have a question about what it was like, working with the university as a partner. Were they more active or more a silent partner? What was that like along the way?
So, yeah, it was. Even though there were pockets that were a struggle to deal with, and I won't say any more than that right now as to who they were. The Innovation Institute was fantastic, and big fans, but not too active. I'll put it that way. They did depend on me to be the driver, and I was okay with that, especially once I found CJ so the Institute for Entrepreneurial Excellence was a huge help in helping me get started and get guidance. Finding partners, they did help me connect with Dick's Sporting Goods to do those early marketing tests. So I would say they were very helpful, maybe more passive than active, but definitely helpful. And the thing that's made a big difference for us, honestly, is they've been a very strong supporter of us, because if we're a success, they're a success. So that sort of partnership has helped. They've been a big promoter of all of our announcements. Anything good that happens to us, they've been right there to support us.
I think this is a great example of someone like you working through the conflict of interest challenges. It's good to see you're successful with that.
It can happen.
Yeah.
It looks like Mike McMahon had a question
Yeah,
here.
yeah. Hey, buddy, this is really great stuff. So obviously the swing is incredibly important. And now you have pitch tracker to show the movement of the ball. Have you done studies where you have swing tracker hitting a pitch tracker ball? And can you do that and kind of get the whole story?
So another great question. So the short answer is not yet. We're looking for a day when that happens. Right now, the ball won't survive those kind of impacts. The electronics won't.
Right.
But we think we're getting close, or we can foresee that being able to happen in the future. The longer answer is we've done it. We actually did it in my basement early on with pitch tracker. I think it was me throwing and my son hitting and my wife doing something nearby to take data. So yeah, it can be done in the lab, but it's just not robust enough for the market.
Right. Makes sense.
But there's a ton of data we could get from that. That was a great idea.
Oh, absolutely. Because that's the art, it's the swing, but it's also being able to handle as they move the ball around the zone on you,
So interestingly, one of our more recent partnerships is with a company called Win Reality. They're a virtual reality company.
Mm-hmm.
They have video of pretty much every major league pitcher. And so you can get their virtual reality app, hit against any major league pitcher using our sensor as the device, and you can get our data in their app. So that's as close as we've gotten right now.
Okay. Be a good scouting tool also if you could get that data of your opposing team, and have your team be practicing against it.
That's right, for sure.
Good, thanks.
It looks like there's another question there. I think you need to unmute though.
Okay. Hi, buddy. This is a really interesting experience. Thanks for sharing with us. So I'm wondering how difficult it is to extend this to another sport, for example, like badminton or tennis, because me personally, I'm actually working in embedded systems in computer engineering department. So I have thought of developing something similar for badminton and apparently tennis too. So I'm just curious, see if you guys have any plans or how what is the main challenge here to transfer like this skill sets to another spot? Thank you.
Yeah, good question. We got asked that a lot early on, from investors. But we specifically chose to stay specific in baseball because we needed to gain deep expertise there, and that paid off. It really did. It was the right way to go. But having said that, some of this transfers directly, right? And all the IMU algorithms and whatnot transfer. It's more of the subtle issues of what does the data mean? What specific data do you want to look for? And then even things like, are there quiet periods? Is it just continuous motion? That does affect how you gather the data. Those are the big differences. So it's not a one-to-one transfer by any means, but definitely a lot of stuff can be learned and ported over. I'd love to talk to you sometime in Benetton. Let's get together.
Yeah, that would be great. Thank you. I probably will send you a follow-up email on that.
Great.
All right.
Thank you.
With that, it looks like we're running out of time. So I'll just say thank you again very much, Dr. Clark. If you can just put your contact information in the chat if anyone has any other questions. I also put a survey in the chat if you're interested in presenting anyone else, or if you know of anyone who's interested in presenting. And then I will also share, just quickly, I'll share the screen and just introduce next month's seminar. Is going to be monetizing your research outcomes, Q&A with George Colston, who's a senior licensing manager at the Innovation Institute. So he'll be anxious to answer any of your questions. It'll be a really interactive session to maybe learn about some of the hurdles Dr. Clark was talking about today. So thank you so much again, and we hope to see you there. And thanks again, Dr. Clark. It was a great presentation.
Thanks for asking. I just put my email in the chat if anyone wants to contact me.
All right. Thanks, everyone.
Take care.